We'll start. So we'll recap what we just did. Give me a moment. I'm waiting for the video to show up. It is. Welcome back to the afternoon session. I'll just recap what we did. What we said is large language models, or more specifically, just language models to use it, have at least three problems. There are many problems, but at least three problems. First is they are obviously very, very expensive to train. So you can't go on. It's not that every 10 minutes you can train a large language model. They're very hard to train. Once you train them on one hardware, then you deploy it onto another hardware for inference. Once you use it in production mode, in inference mode, they nevertheless have crucial problems that is hard to avoid. There is no way around it. One is the problem of hallucination. Nobody has solved it. Tremendous research is going into figuring out how to prevent the LLMs from hallucinating. We have improved the situation quite a bit, but it hasn't been solved. The second problem is the inherent staleness of data. LLMs, you take a checkpoint at training, you deploy it to inference in inference mode in production. At that moment, it knows what it was trained on. Soon it's old, months old data. And that creates its own limitations. So news inherently is something that becomes hard to use with a language model. Now, the reality today is most people find it natural to talk to a language model. It's the closest thing to human conversation, isn't it? When you talk to a language model, it feels natural. We would rather that it not be stale, that it could tell us about what happened yesterday. The next problem is, from an enterprise perspective, quite serious. Enterprises sit upon proprietary data, non-public data. LLMs inherently are not trained on proprietary data. That's dark knowledge. That's not there. But dark knowledge is not just inherent to enterprises. Dark knowledge is about our own lives. For example, if you want to talk to your own medical data, you don't want the LLMs, public LLMs to be, or corporate LLMs to be trained on your own medical data. And yet, knowing your medical data, see, what you don't have is a MD, right? But you do have, because of HIPAA laws in the United States, all of you have access to your own medical records. Now, obviously, it is not advisable to try to be yourself doctors. Nevertheless, you might want to ask a language model that if my A1C is just borderline, let's say it's 6, hemoglobin A1C is 6. Am I diabetic? Am I not diabetic? Do I need to exercise? What is it? Right? Those are basic questions. Perhaps for that basic question, normally you would go Google anyway, right? You would meet your physician. Maybe your physician's appointment is 1 month away. You're feeling a little bit restless and you would like to do some quick search. You can search and spend a lot of time on the web. Alternatively, you can just ask, what does it mean? Why would you ask that? Because LMs have been trained on all the medical data. For example, as you know, there is this data set. Sukhpal, what is it called? The fourth version of which we are on, not Epic. What is that called? The name is escaping me. Anyway, all the medical histories of people, there's a public data set, or rather professional data set available only to physicians. These language models have all been trained on that data set. They have been trained on all the medical textbooks, right? There is credible evidence. Actually, they have become...
Mimic, sir, Mimic?
Mimic, exactly. Mimic 4. The Mimic 4. The Mimic 4 is a data set on which they have been trained. Textbooks, they have been trained. Medical knowledge. They have they have studied all of WebMD articles, right? And research papers and everything in the public domain. So you can ask, what should I do given my health condition? So when you ask it a natural question, what can I do given my health condition? Open LLM, whether commercial or open source, does not know your medical condition. it is inadvisable for you to publish your medical condition, medical data on the internet so that the next iteration of the LLM would learn on it. But instead, this is a perfect case for RAG, isn't it? You create your own little search index in which your confidential data is there, put a LLM in front of it, and now you ask it a natural question. So that brings me to an important point that I haven't mentioned, but I'll talk about. Where is the real power of a RAG? What is the value proposition coming from? Now, I said that the way it works is in 3 stages. First, you maintain a template. It is a template that will augment a user's query, user's prompt. So that's a retrieval-augmented prompt. It's a template. Whatever the user says, you go into your knowledge base, get search results, and you fill in the blanks in the template. You do substitutes in the template, right? You make it. Your step is, given a user query, first search for in your search index. Implicitly, I assume the search index is semantically aware. It's a semantic search index, the kind we have been talking about in the last 2 weeks. Later on, I will say that it's a hybrid search index, but we'll keep it. And then I will tell you that in reality, if you're a large enterprise, you search many indices and you do a whole set of re-ranking and many things. So the real life gets a bit complicated, but we'll learn of that as we make progress with the course. You open your template, you replace your placeholders with that. So ultimately, your retrieval-augmented prompt now becomes this. You're given the following facts, whatever the search results were. Using this above as additional knowledge, now answer the following query. Who are the current, whatever the question query was, right? So for example, your query could have been, do you think I need to worry about diabetes? So when you give a question like that, you realize that's a very general question. It is self-referential. The language model needs to know who I am. It needs to know we are talking about diabetes, but both of these things can be searched for in the private search index, isn't it? And then inferred. And from there, the moment it is diabetes, you could therefore search for of course, one of the biomarkers, which is hemoglobin A1C, which typical panel tests do. And based on that result, now the LLM is capable of giving an answer saying, yes, you are borderline, you better start exercising and forget about that daily rasam chawal, rice and rasam, right? So that's the power of this, and therefore retrieval augmented generation. Now I'm going to pivot and ask this question. We are looking at it from the perspective of amplifying an LLM and mitigating its shortcomings and making it useful on confidential data or more recent data, right? Mitigating hallucination. There are many, many advantages of retrieval augmented generation. I'll leave that to you. Now, I'm going to look at it from a few different lenses. Let's look at it from a search result. Now, when you search in Google, what happens? Well, these days when I go and search in Google, it's a form of, I don't know, I'm getting more and more irritated because I tend to, you would rather that the high value results are at the top. Actually, advertisements are at the top, right? It's become a nuisance, a whole page of advertisements, and then way below that, you have to search for the search results, right? Then you have the search results, which are somewhat relevant, but see, it is giving you are asking this question. Now, let me ask a very direct question. Let us say, you say, my hemoglobin A1C was 6. A1C was 6. What does it mean? And it will take you to an article. One will say, hemoglobin A1C is a measure used to test whether you have diabetes. Here is a scale. Here is what its definition is. After many pages, you realize that, okay, here's a table that tells you what it means, right? Another article will immediately tell you, in case you are worrying about diabetes, we have an excellent diet, right? And here is our special supplement, patented, of course, right? Or if it is India, it is Unani medicine, Hamdard medicine, or Ayurveda, or whatever, right? You have to filter through a lot of nonsense before you get an answer to your question, which basically says, dude, go out and jog, right? You see that it doesn't answer your query. It just gives you the relevant answer, and you need to digest and answer yourself, isn't it? It just arms you with knowledge, but doesn't answer your question. That's a fundamental limitation of search. Search engines don't answer questions. They just arm you with relevant knowledge. And then you have to parse and make sense of it, isn't it? Now look at it from a language understanding perspective. What is the whole point of a language model? These are natural language understanding machines. They understand natural language. So what can they do? They can do what you did. Given a bunch of facts, they can digest it and they can relate it to the question you asked and give you an answer to the question. Isn't it? Are we making sense? And therefore, do you realize, is it a surprise that many of us almost never visit a search engine anymore? Right? ChatGPT, in my case, I have my own RAG implementation that I use, right? In which I actually have index news that's coming in, and I've indexed my relevant sources of information. The beauty of that is there are many things I don't care about in the world, right? And there is no way I can be bombed with advertisement. I want to search for things, I search in that. I use my own RAG. Right? And I invite you to do that. It's really very useful. It takes some effort, but if you do it, you'll be doing yourself and your family a huge, huge favor. Because obviously the nature of the web is, why will somebody put some information out there in public? Two reasons. Genuinely, they want to share information, but if the information anyway admits a debate, you will get biased opinions, right? It will always come with an axe to grind. It will come with a bias. You can choose where you tap in as a mind, like I have grown up in a mathematical scientific tradition, as most of you must have figured out. I am no-ism. The people say, are you capitalist? No. Are you a communist? No. Right? Do you believe in God? No. Do you not believe in God? No. Right? So I live with questions, not with answers. Right? So it's just a personal statement. So if you're like that, who would like to say, at any given moment, give me the facts and no more than the facts. Right? Then you need to create your own RAG system from trusted sources. So this is, by the way, very real. One Harvard researcher did a simplest, this is the beauty of elegant experiments. She sat down in one of the liberal states, I believe in California, and typed in the word in Google, global warming is a, and Google does auto-completion to help you, and it immediately said an existential threat. She repeated with the same laptop, the same thing. She went to one of the red states, let's say Mississippi or wherever. She said, global warming is a complete hoax. The same search engine, right? So what is it doing? At any given moment, it figures out that if it panders to your biases, you are more likely to visit it and use it, right? That is the danger of blindly using other people's technology, right? And we are talking of something that claims to be a public utility, basically, right? Not to single out Google, I'm sure every one of them are doing things like this, right? So that's the value of RAG. Search. Take your own search. If nothing else, you can choose your knowledge sources. Secondly, you can have a natural language conversation with the data. So that is the second lens to look at RAG with. Mandeep. Yeah, absolutely. It can be biased. But what happens is that, and this you learn when we do prompting as a depth, the information that you give in the this input, the prompt, generally tends to supersede the inbuilt knowledge. It relies more on that. You can force it to rely more on that. Yes, we will come to that also. That is the tooling. So let me repeat the question that is here. If it doesn't find the answer in my knowledge base, it comes out empty. Where will it answer it from? There are two ways of it. If you have armed the LLM with tools, so that is the agentic reasoning. That's a course that I'm teaching on Thursday. Um, then it can go search the web. Or like, for example, you notice that ChatGPT these days is doing that. Yeah, that is in augment. If you do that, they're basically doing RAG. What is it doing? It is ragging on the internet, isn't it? It's doing that. And otherwise, it has its own memory. Whatever it has learned, it will answer the question from that. Right, Damu? So that's a second lens. There is a third lens to look at it. The third lens to look at RAG is, and that's why it is called, in which the word retrieval augmented takes a new meaning. It is a memory augmentation. See, we know that these language models, because they have billions of parameters, they have the ability to remember a lot of things. By the way, in the beginning, it was a debate. Do language models remember anything? Or are they just statistical predictors? Next word predictors. People argued it's next word predictors, so inherently it can't do copyright violations. Till, of course, was it New York Times? New York Times sued and showed that what it produces is almost a verbatim reproduction of its passages. Right? So therefore, you can't argue with evidence. The evidence is it has somehow reproduced it exactly. Right. So it stores it. Today, a lot of research has shown that in the dense layers, in the feed-forward layers, and that's one of the things I'll give a Wednesday research. Guys, are you aware that we give the Wednesday research paper seminars? In the seminar series I cover, and I'm going to cover that topic actually. Where exactly is that knowledge hidden in a language model? Right? But language models have a capacity to remember things. So it has a memory. And when you ask it a question, it is doing both. It is retrieving from the memory. At the same time, it is a next word predictor. Both statements can be equally true. Right? So, but then if it is not there in its parametric memory, then there's a risk that it may hallucinate or something like that. What is your search index doing? It becomes augmented memory, isn't it? Besides the parametric memory is the memory that is there in the parameters, the weights and biases of the language model, right? Which is finite at the end of the day. You can now augment it with the search index. Now, the reality of search index is, if you have ever done search indices, you realize that tremendous amount of knowledge can be pumped into a search index, and yet the search indices are small. Vector indices are very small, right? Ultimately, these are points in an n-dimensional space. How much space are they taking? They're just taking the amount of space. So suppose you're projecting it into a 768 dimensional vector space. You have 768 floating point numbers to capture a text, isn't it? It's actually an extraordinarily compact representation of knowledge. So even massive vector indices are actually pretty tame in size, right? And you are augmenting that, therefore, the LLM, the language model's memory, with a retrieval memory, which can be orders and orders of magnitude bigger than what the language model remembers, theoretically. So now take this, look at it from a different lens. I need the language understanding capability of the language model. I may not care so much about its internal memory, especially if I'm dealing with enterprise data. In fact, sometimes the internal memory, the parametric memory of a language model may be detrimental to my cause. I don't want it to tell me the answer from its own knowledge. I want it to derive the answer only from the search results. Are we together? Take this example. Suppose my product actually sucks compared to the competitors, but my internal documentation says, wow, absolutely the best marketing product. Do you want this language model to look at my results and then also remember that the other guy actually has a much better product and say that in the answer in customer support or in customer sales chat, customer conversations? You don't want it to do that, right? So sometimes it helps if the language model's abilities that it has, you would rather that it foregoes it remembering facts and you only use its language understanding abilities. You see that, right? The language understanding abilities is what you need. So what you could do theoretically, if the language understanding ability is all you need, you realize that you can get away with very small language models. You don't have to start with a language model that requires a massive GPU. And you will see that most people get away doing RAG with the kind of language models that fit in. I mean, see, 4090 is what? $2,000 these days in US. A 4090 often serves enough for most RAG cases in small companies. Just one GPU, $2,000. That's it. That's exactly the machine we are giving you. The next level of escalation is you can go to a 48 GB, like you can go to a A6 6000, right? Uh, and or you can put a bank of 3, 4 of them. But even if you do that, you're still talking of a machine that's 20 to 30, 20 to 40,000. So the inference server here is a $40,000 machine, right? With a bank of GPUs. That's enough. And so you can do excellent RAG, high performance RAG, right? With a pretty high volume throughput with that, because all you care for is the language understanding capability of the machine, isn't it? So that's the next lens to look at it. So, third perspective. There is yet another perspective, which is the systems architect's perspective, which is the cost and efficiency perspective. See, I said that to teach a language model something, there are three ways. You could do full blown training from scratch, massively expensive, right? Only the hyperscalers of the world can do it. You better have your own power station or a sweetheart deal with a power station to deal with it. In California, for example, how much do you guys pay per kilowatt hour? 60 cents, right? 60 cents. Do you think at 60 cents you can afford to train any model whatsoever? Even if you could buy the hardware, you can't, right? So that's one real consideration. The second aspect is, well, you say, forget about training from scratch. I will do a fine tuning. Fine tuning is the lesser, by orders of magnitude, less expensive journey. And fine tuning is something is advisable, right? But there is one thing that comes practically free in the grand scale of things. If you do what is called in context learning, namely in the prompt itself, you tell it, give it enough facts to answer a question. These language models, off the shelf trained language models, can just read the prompt and answer the question, isn't it? It is called in context learning. In RAG, what are you doing? You're doing in context learning, right? From a search result, you're feeding it the enough facts for it to answer a question. How much is the model training cost? Zero. The model is in pure inference mode, isn't it? It is only doing inferences. Off the shelf model, you get it, deploy it. Pick your size, whatever size works for you, right? And what does it cost to create a semantic search index? On the grand scheme of things, almost nothing. Not much, not much, not much. So, well, not much is relative. If you have, for example, if you have a 4090 running, a 4090 at peak power utilization is about 700 watt per GPU, right? 6 to 700 watts per GPU. In low load condition, the minimum is about like 100 watts per GPU. 100 watt is a light bulb, right? 100 watt is a light bulb that you're running. So you're not consuming that much power. But it's not that you're not consuming. Your bill will go up, electricity bill will go up, but modestly, isn't it? So that's the thing. But to do RAG, do you really need even a 4090? You don't. Actually, a modest 4060, which consumes far less power, will do. In fact, you don't even need that. Macs, which have ARM processors, and Mac always has a good marketing name, right? What do they call it? Neural engines. What is it? Neural engine? Neural processing unit? NPU, neural processing units. Okay, Mac has always a flair for the marketing. So first there was artificial intelligence, and now there is yet another new form of intelligence, Apple intelligence. Okay, that's right. Yeah. So there's a lot. In fact, I would say that RAG, because the models are in inference mode, if you have a small LLM, you can even do it with just CPU, right? And CPUs these days are like $90. Right? So from a price perspective, therefore, RAG is very inexpensive. Next thing is, and that is why, so now I'll talk a little bit to the practical application. So you can say, why not use the best of both the worlds? You could do this. You can fine tune open model that you have downloaded onto your private data and then do RAG with it. So then you get the benefit of both fine tuning and RAG, right? But generally, I would advise you, see, your course of action should always be least effort first. The least effort path is RAG. Do that because that is your path to riches, right? Make your business thing and then you have RAG to riches. Then if it need be, then you fine tune, but generally don't go training a model from scratch. So guys, there are 4 perspectives I gave you. One is from the perspective of LLM. You can mitigate hallucination. You can solve the problem of staleness, isn't it, of the LLM. And you can solve the problem that it doesn't know things that are not public. That is one perspective. Look at it from the perspective of search. Search results, when you want a question answered, search engines don't answer the question. They just arm you with knowledge to answer the question yourself. Whereas a RAG will answer the question because the language model will understand that knowledge and answer your question. So that is valuable. Yes. Absolutely. And by the way, perplexity is RAG. It's RAG. It's an IIT kid who did it, right? It's RAG. It started out as RAG. See, RAG itself, there are different levels of sophistication and complexity, but it's RAG.
Page ranking, yeah, absolutely.
Yeah. And by the way, you just discovered your next project. Guess what is it? Reinvent perplexity. Literally, I'm not kidding. That's your next project. So what you have to do is, I'll give you the ability to search the web, right? That API will return you search results, and you have to recreate perplexity. That's your bootcamp project, actually. Yeah. They give you the search. That is it. That's the beauty of a search engine, right? That is right. Mandeep, think about it. If you have searched the web, you know where you have a reference to the document, right? You guys did search. Don't you have a reference to the doc? So when you give references to the doc, it is the clearest indication that you are doing RAG, isn't it? That's the power of RAG. Inherently, freebie is that you have a reference to the doc. question? No, no. Think about it this way. The user entered, okay, see guys, you missed this. What did the user give? Just a query. This is what the user entered. Imagine perplexity. This is what the user has entered. Internally, you do everything else, isn't it? That's that. And so, guys, go. So now I'll give you another example. Let us, I mean, obviously, everything we say is speculative at this moment. So if Perplexity is doing more heavy lifting, we don't know. But we certainly know they're doing RAG, isn't it? Think of Khan Academy. How many of you have used Khan Amigo, or your kids are using Khan Amigo, right? And Khan Amigo was supposed to be the greatest thing in education since sliced bread or since a teacher was invented, right? Because now every person can have their own tutor. Guess, now connect the dots to RAG. What is it doing? Imagine that your prompt says, when a student asks a question, do not give it the answer, but give it only hints. Using what? You don't know what the question is about. What will you do? You'll dip into the knowledge base, gather the facts, and all you need to write is in the prompt is give hints, don't answer. And therefore, your next project in this course, and I'm giving you deliberately real life projects, you need to reinvent Khan Academy for me, Khan Amigo. Right? I'll give you the solutions, guys, at the end of it. And you will see, guys, what I'm saying is that the things you are learning here are world changing, are really empowering. Do your labs, do your projects, and you will realize that giant gazillion-dollar companies are built on the backs of these simple ideas. Just implemented well. Like somebody once said, right? Ideas are dime a dozen. Like somebody who invests in, what is that thing? What did somebody once say? He said, so sitting on the VC side, he says, if he throws a stone at Silicon Valley, it will hit a guy who's walking around with yet another algorithm, right? The problem is, how many of them are willing to work hard and take it to success? Yeah? So guys, if you are here, take your ideas to success. Do first-class implementations. Because if you do it, as has happened in previous batches, that room has produced a startup, that room has produced a startup, that room has produced a successful startup, and that room there, the first room there, has produced a successful startup. Already well-funded startups that are well on their way, right? And where Abraham is sitting, a guy has not only done a startup, is earning 165 million a year. Right? You can do it. It's all about putting in the effort and doing it, having the ideas and doing it. So that is about RAG. Is it making sense, guys? Now, RAG. So now I will come back and let's look at one thing in the room. See, this template and this prompt, this is an exercise in prompt engineering, isn't it? It is not you just writing something and shooting it off to a LLM. What is it? It's very carefully creating a template into which facts are embedded, queries embedded, and results come. So that brings us to the next topic, which is that, and which is the second half of RAG, a good prompt. And I will use that as a segue into the whole world of prompt engineering. Are we together? And I will show you what prompt engineering can do. So think about it this way, guys. If these language models know everything, there are 1,000 PhDs hiding behind the curtain, right? So I don't know, how many of you have read the story of the Wizard of Oz? What? So Wizard of Oz, right? And the thing is, Dorothy and Tin Man and all of them, with great anticipation, they go on the yellow brick road to in the land of Oz to meet Oz, who is behind a curtain. And is supposed to be an oracle who can answer all questions. And they ask a question and they don't get satisfactory answers till they look behind the curtain. And what do they find? What's that? There was just a guy sitting there, right, who was really not any kind of wizard at all, right? And well, I suppose there's I don't know why I'm remembering it. Actually, the author of that book used to live very close to in a place called Casanova in upstate New York, and for some time I used to live close by. So if you go to Casanova, actually, you will find the yellow brick road. Children walk on that, and there are little ice cream shops and things. They've really done it very well. And there's a Chitanago Falls, a beautiful waterfall, and it's a beautiful place. Anyway, what I'm saying is, language models are the opposite of Wizard of Oz. They actually are wizards. Right? They are very well educated. They have the knowledge of 1,000 PhDs in them. Right. How does a language model summarize text that you give it as input? Well, uh, we know that it can do it. We have trained it to do it. But how it really is able to do it in such an intelligent way, more than we can, is a mystery that remains to be solved. Absolutely. See, neural networks are a mystery. We don't understand why they work. Nobody understands. Right? If you ever meet a person who says, "Oh yeah, man, I absolutely got it. I know neural networks. I understand neural networks." One thing you can rest assured, that guy is clueless. Right? That's right. Yeah, that's right. So, so yeah. So there are two things there are two mysteries. There are two subjects I've been through in my life, which are mysteries. The more you study them, the more mysterious they look. I used to, in a past incarnation, when I was very young, study quantum field theories. And the more I studied, and I have published research in that, the more I studied, the more I came to the conclusion that nobody understands what it means. And there's a famous saying of Neil Bohr, one of the great quantum physicists, who says, anybody who thinks he or she understands quantum physics is clueless, basically. Right? The same is true for deep learning. And by the way, there's a deep connection between theoretical physics and deep learning. A lot of the architecture of deep learning is being reinterpreted in terms of physics. Right? So we don't know how these machines are able to do this. We understand some of the pieces. And if you are in my Tuesday class, you will learn all about it. You'll learn all about gradient descent. You'll learn all about backpropagation. You'll learn all about attention, autoencoders, variational autoencoders, diffusion models, right? Kolmogorov-Walnor networks and Mamba and Jamba and all sorts of convolutions and whatnot. And I'll fill your minds with all sorts of neural architectures. But the more you learn, the more you'll realize that we actually don't know much how exactly these machines think. Right? So that remains a mystery. So, all right, guys, I'm going to end the topic of retrieval augmented generation. Now you know what you have to do. You have a search result. Now what you do is add a language model to it. So don't return search results, but return an answer, a meaningful answer to the question. Right? And I invite you, if you are interested, I started recording my lectures through the pandemic by necessity because the lectures became remote. Otherwise, it used to be just in person. So there are about 500 lectures on YouTube. They're all public, 500 public lectures, a sum total of about 1,500 lectures. So apparently, I've given 1,500 talks since the pandemic started. The 500 lectures that are there, I can give you the transcripts of all of them. Right? There is two ways of getting transcripts. One is the Google transcript, but that's sort of low quality. The second is you can generate it using Whisper. By the way, I'll teach you. That's one of the things you'll learn. Voice to text is one of your labs later on. But you will do that, take any video and get text out of it, transcript out of it. But for now, you'll use Whisper Model 3, Whisper version 3. But for now, I'll be kind and I'll give you the transcripts. These are generated through Assembly AI, which is a little bit superior to Whisper. If you want to do a RAG on that, I invite you to do it. So I'll tell you what people in the previous batches did. One of the teams, what they did is they took my transcript, they put a RAG, and what they did is in their prompt, they completely wrote a template that would mimic my style of talking. And then they used a text to speech, which was trained on my voice, right? And when you ask it a question, it comes back with an answer that speaks like me. And it was so believable that most people thought I was talking, I was giving answers, right? Yes, I'm not kidding. The demo is still there. So any team that is takers for that project, do that. Yeah? And do you realize that I've given you all the ingredients to do it, right? And in 11 labs, there's already a model trained on my voice, and that speaks like me with high fidelity. All you have to do is write text, make a language model, imitate my style of speaking or joining words, produce the text that plausibly is the way I speak. And once you have done that, you can convert it to uh, video, audio, audio. And then one team went further, actually. They created a video of me. So now it is me standing, speaking the way I'm doing to you in my voice. Come again? Mhm. Yeah, actually, 11 Lab does that for you. You give it your sufficient voice recording, and you have to authorize it to train a model on it. It will train a model. It's very dangerous. You realize that with that, you can make me say anything. Right. So if you want to do, so that's a state of the art. And so what I'm telling you guys that, do you realize that once you learn RAG, you can come within shooting distance of what these guys have done, what Perplexity has done. You can have your own, at least the framework, the core ideas of Perplexity, the core ideas of Khan Amigo done. Do it, guys. Huh? It is no use me just giving you solutions. Huh? Do it. And if you guys do it well, then I'll give you only the teams that do it well, I'll give them the solutions. How about that? Is that a fair bargain? Right. Yeah. If you try it well, you get it. So, and it's very impressive actually. At the end of it, when people had a big laugh when they could see on the screen me giving answers. And one of them actually wanted to go productionize it. Right. So that's that. All right. So that finishes the topic of retrieval augmented generation, a really big topic. Now, I will, just before I close the chapter on this, I'll add two more dimensions to it. Nowhere did I say that your search content should only be text. What else can you put in there? Images, voice, videos, isn't it? More than that, you can put tabular data, charts. Yes, exactly. Charts, figures, everything can be put into that. And in fact, this course, I wouldn't stretch you so far, but those of you who get interested in RAG, and I hope it has piqued your interest, the power of RAG. If it interests you in October, when the advanced RAG course starts, the RAG to riches, right? You're welcome to join in. There's a precondition. I don't let anyone join that course unless they have taken this. Yeah. Because I don't want people to slow down the course. So you will have the opportunity to join it. So in other words, multimodal RAG, multimodal input, multimodal output, right? That is the state of the art today. And the best part is you can do it on relatively inexpensive hardware. Let us close the chapter then, and I will go now into prompt engineering. We'll take a 10-minute break. We'll follow the 10-minute break with a presentation by Manju. And after that, we will